In the notes for today, we're going to be looking at a continuation of basic mapping, understanding, and then we're going to enhance it onto overall time zone explanation. In the notes, you'll learn and understand how to use maps, globes, and other geographic representations, tools, and technologies as we progress our way through our geography unit. So let's get started. To begin, we start with latitude and longitude lines. The Earth is divided up into lines, imaginary lines called latitude and longitude. And these two lines are used to create various different grids throughout the planet. And this is done by an extensive set of satellites that are constantly being added throughout the year. But this satellite network is found up in our orbit. And because of these satellites, longitude lines run north and south, latitude lines go east and west. And to measure the distance between each of these lines, that unit is called degrees. Now the equator is the 0 degrees latitude line, west to east. The equator is an imaginary line or belt that runs halfway between the North Pole and the South Pole. And because of that, the equator divides the Earth up into the northern and southern hemisphere. It tends to also have a lot of precipitation, rain in particular, around the equator. However, the prime meridian is 0 degrees longitude, north and south, and this imaginary line starts in Greenwich, England, the time zones, and then goes through France, Spain, Western Africa, and Antarctica. You will note these are zodiac signs, but the tropic Capricorn marks the most southerly latitude at which the sun will appear directly overhead at noon. The day this happens is December 21st, the December solstice, and in the southern hemisphere, that marks the brightest, longest day of the year. However, in the northern hemisphere, you will know December solstice does not mean that. It is the exact opposite. It is the shortest daylight in the northern hemisphere. But that's because of the Earth being tilted on the axis. So in the northern hemisphere, December solstice is we are further away from the sun. But in the southern hemisphere, for countries such as Argentina, Chile, South Africa, or Australia, it is the brightest day of the year for them, for the December solstice. For the Tropic of Cancer, this is like before, but it will appear on the 21st of June, the summer solstice, the June solstice for places like Mexico, Libya, Egypt, Saudi Arabia, India, even parts of China. Like the previous line, this is called the Northern Tropic, and that marks when the new sun is a high noon day. Along with that is, of course, the directions. Linking back to before with the satellites, longitude, latitude lines. These are all imaginary, but this forms that GPS grid. GPS is short for Global Position Services. It is actually quite incredible, really, how much technology now has GPS in it. Everything has GPS technology in it, even Apple Watches and small boxes. GPS is a very common technology, and some of the companies that are really big in GPS is Magellan, Garmin, or TomTom. But in recent times now, companies like Apple, Microsoft, Google, Samsung are also becoming very prevalent in the GPS technology market because, as I said, kind of everything has GPS technology as we become more and more integrated and networked with each other. Now, as alluded to before, maps are made to scale. That is, there is a direct connection between the unit measurement on the map and the actual distance, right? It is a representation but a much more smaller, manageable size. For example, for each unit on the map, it can represent 1 mile or 1 kilometer on the earth. So a map of a town will show just a mile-long strip for fast food joints or car dealerships on it. Scales, like I was mentioning in the previous notes, you first have the title, then legend, compass, and then scale there. Every map needs to have those components included. On to the last piece is then the time zones. Now that we've covered the equator, the prime meridian, the compass portions. On Earth, there are 24 time zones, 24 different time zones. And that is because literally takes 24 hours a day for the planet to finish one full rotation. Each time zone has a 1 hour difference, where a few places may only have a 30-minute difference, but most time zones is 1 hour difference. In Canada, there are 6 different time zones: Pacific Standard, Mountain Standard, Central, Eastern, Maritime, and then Newfoundland. The first 5 of those are in 1 hour difference. Newfoundland, however, because it is an island, the time difference is only 30 minutes instead of 1 hour. But in British Columbia, we have 2 time zones, Pacific Standard and Mountain Standard Time. Most of the people in British Columbia, as well as in the Metro Vancouver-Fraser Valley region, we live in the Pacific Standard Time. So we are 8 hours behind the prime meridian. As the Earth rotates, the sun shines and moves in different places, going from east to west. The hours will change. The actual idea of time zone differences originated in Canada. Sir Sanford Fleming, as we're going to learn about him, was involved in the building of the Canadian Pacific Railway, and he realized what is noon in, say, Winnipeg is not the same in Vancouver, or just name it is different. Other things to think about when it comes to time zones: if you're moving east, meaning you're moving towards the prime meridian, you are gaining hours. If you are moving west, you are moving away from the prime meridian, so you are losing hours. Prime meridian, Greenwich, England, is where the time zones begin. And since the planet is 360 degrees around, take that 360, divide by 24, being the hours. Every time zone has a difference of 15 degrees difference between one zone to the next. But not every time zone will follow in perfect straight lines. As an example, with the international date line. Time zones lines will wiggle and squiggle and go in different directions based upon political boundaries and or actual physical boundaries. But the international date line, like I always say, is another imaginary line, but it goes north to south. Essentially, the international date line marks halfway, either west or east, but still halfway from the prime meridian. It is also located exclusively all in the Pacific Ocean, but as you see on the map, it does not follow that one side. If you are going west over the prime meridian or the international date line, you automatically gain 12 hours. But if you're going east over the international date line, you lose 12 hours. It is literally a difference between daytime or nighttime, depending on which direction you are going. This can be one of the greatest causes why, for anyone who flies internationally or over the international date line, jet lag can be a real struggle to overcome. But the international date line is 180 degrees longitude because it is halfway past the prime meridian, which is 0 degrees longitude. It is also a reason why countries such as New Zealand or Australia are usually the first ones to always celebrate the start of a new calendar year. And to wrap up, the legend is the key to unlocking the secrets of a map. The legend gives you names to what you see on the map. The key is found on the back part of the map, which explains, as a short sentence, what each legend symbol is supposed to represent.